Hello everyone. I welcome everyone to the first Cosmwasm workshop. So today we'll be actually covering how Cosmwasm works, and you'll also get to know about how all the dependency actually works on Cosmwasm. So let's get started with it. So when talking about Cosmwasm is basically a smart contract development platform on Cosmos ecosystem. So as you all can see that Cosmwasm is basically derived from two words, which is Cosmos and WebAssembly. So Cosmwasm is derived from basic two words. So Cosmwasm is basically a module named Wasm module, which is actually plugged in Cosmos SDK, which is meant to create smart contract on top of it. And the primary language that is actually written on Cosmwasm is Rust. So let's talk about the architecture of Cosmwasm. So basically, as I have said previously, that Cosmwasm is basically a Wasm module which is written on Golang, where people people can write Rust Rust smart contracts on Cosmwasm and deploy it on Wasm module where they can directly interact with different contracts and such. So here's a high level architecture of how it actually works, where you can see that the Tendermint is basically supposed to interact with Cosmos SDK via ABCI, which is application blockchain interface. So uh, here you can see, just a second, I'll just start sharing my screen. So as I already told that Cosmos is basically works upon Cosmos, which is actually Cosm, and WebAssembly, which is Wasm, which is combined together as the Cosmwasm. So Cosmwasm is basically a module which is actually written in Cosmos LTK, where user can actually start interacting with the smart contract, which is actually written in Rust. So kind of let's start dig into the actual architecture of how it actually works. So here you can see that a user actually can interact with the Cosmos SDK, where we have a Wasm D module which can interact with Wasm VM and libwasm VM. So we'll start going into that in details when we start with the different workshop of how we can actually write a smart contract. But basically, you can just try to understand that how basically a Cosmwasm architecture works, where we actually have a Wasm module which has the ability to have all the Cosmwasm contracts written into it and can directly interact with it. So there are quite a few there are quite a few key points that are considered which can be considered for Cosmwasm module is code upload, instantiate, and execute contract. So most of you must be familiar with how contracts are actually written in Solidity, where once you write a Solidity code in .sol file and you combine it and then you deploy it. And once you actually deploy it, you have some instance where you can provide some input values, and based on that, you create a basically a Solidity instance or a contract address is instantiated based on it. So based on that particular thing, you can actually imagine this thing, yeah, of how Cosmwasm basically works. Where once you have written your Cosmwasm load in Rust language, the first thing actually comes is like uploading your code to the Comdex, like the Comdex. So this is the first functionality which is provided by code upload, where any .wasm file or a WebAssembly file is actually uploaded to it. Second comes is an instantiate contract. So you can consider it as once you have deployed any code, so that code holds no value until unless some state or some values or some instance is actually provided to it. So instantiate contract is that particular thing. And then comes execute contract, where once you have instantiated a contract and you have got an instance of it, and every instance is determined by a contract address. So based on that particular contract address, you try to execute a contract or write a query for it. So this is what the base code logic of Cosmos and how it works. So we'll try to get more in details of how it's more similar, like it is more similar to how Solidity works in Ethereum or say Polygon network, where, for example, like contract initiation as well as execution is actually muted by a required guess, where you must be familiar with the gas thing, where how every calculation or every transaction actually executes some need requires some gas to perform. So same goes with solid Cosmwasm as well, the way it works in Solidity, where for every operation that you perform in your core logic, it requires some gas. So you need to actually provide those gas to in order to execute a transaction. So so there are quite a few things that is actually better in Cosmwasm compared to Elastic. In Cosmwasm, you can actually send tokens via bank module, well, and which is actually a plugin point for everything compared to what you actually have in uh, Solidity part, where you actually need to interact with different uh, seed, uh, you say ERC20 token to at least send the tokens. So this is kind of a plus point for that. And one thing to know that Cosmwasm has a steeper learning curve than the Solidity. And when I say about the steeper learning curve, so Cosmwasm actually works on high optimization such that the gas optimization, also the gas requirement can be minimized based on that. So consider for an example that when you write a Solidity code, and you might take multiple iterations to work on it, but there are chances that once you actually build a Solidity contract, it might fail at some particular point of time. So that is something that can Cosmwasm actually negate from their side, where so whenever you build a Cosmwasm contract, it tries to negate all those failure points or checkpoints that can actually cause a failure in your Solidity in the Cosmwasm contract. So currently, Comdex, talking about the Comdex, which is a chain, actually implements a permission Cosmwasm on chain, where you need to upload your contracts in a permission manner. And when I say permission manner, it means that user actually have to create a governance proposal for it. And once the governance proposal is passed, people are actually able to upload that code and even interact with it. So for the time being, the hackathon, we actually launched an overnight, which is a Comdex overnight, which will actually be a Comdex permissionless chain where people can actually use that particular feature to upload any particular contract permissionlessly and interact with it. And also one more thing to point out that whenever you say, for example, in Solidity, whenever you actually have some contract instance already deployed, it's very difficult to migrate to a new code and then point your whole contract instance to a particular new code. This is something that is actually tackled by Cosmwasm, where you can actually use a particular. So let's assign one code of, for example, creating a counter where account complete itself with increment of one every time it is solved. Now, suppose I want to actually update the code with some logic where that particular counter has to be updated twice every call. So I can just upload a particular code and just point my previous contract instance to a new code, which is very feasible in Cosmwasm compared to Solidity, compared to like writing a migration code for Solidity for Ethereum or say Polygon networks. So let's take some example of let's take so since we have gone through all the examples, let uh, try to understand like what are the requirements that you actually need to have to start working on Cosmwasm as well as Rest. So let's see for an example. We'll just go to Dora X. So on the developer resource, you can actually go through the hackathon instruction guide, where it will be showing you like what are the pre-requirements of using a chain on Cosmwasm. So you can see that we actually require a Go version of 1.19 plus, which will be required to install the Comdex chain as well as installing Rust as a must for all. And Rust, like knowing a basic of Rust, is a prerequisite for every developer who aspires to create any project on Cosmwasm. So this is the instruction that you will be given in that GoAX official website. So apart from this, now we will start going through. Once you have actually installed these four dependencies, we'll actually tell you like how to particularly install complex binary and interact with our test chain. And we'll also show you how actually Cosmwasm look like and what are the key features that are available there. So, so according to the document, it says like first we need to actually clone that particular repository. So first of all, let's start with git clone. So here we'll just start a new window. Since Golang is already installed in my system, so I can just verify the installation by just writing Go version. So here you can see that Go version of 1.1 is already pre-installed in my system, which is a prerequisite for installing the complex binary. So let's just create a hackathon repository, hackathon directory right now. We'll start with cd mkdir hackathon underscore v1 cdmk. So now we will start with update, like we'll try to get into. So we'll start with cloning it. So let's just create the whole clone part. And here we will. All right. So we are done with cloning our Converse repository. So basically, Comdex binary is required for interacting with test chain, and which is the prerequisite for interacting with any hackathon test chain. So please pay attention to this carefully. So now we are in hackathon v1. So I'll just give you a brief example of it, like how the whole Comdex binary looks like right now. So you can see that these are a set of modules that we actually have, which was actually explained by Rohit in the previous workshop, where we have asset, auction, band oracle, and various different modules. Apart from that, we also have a WASM module, which is actually imported from Cosmos SDK. So we will be using that as well. So our first requisite is to make install it. So we can actually follow the previous example of how to actually install Comdex repository, like how to install Comdex. So on the Dora hacks page, developer resources, once we go through the Comdex instruction guide, we can see that once we have actually imported like once we have actually cloned that particular repository, which we can see here. Let's just start the terminal. And the tag we actually have to use is hack v1, which is designed for Comdex test network. So, so we'll just click get checkout. Right, flash v1 file. Yep, I'll just copy it. The tag we are actually going to use. Now, second is to do a go mod vendor and then make install. So I'll do a go mod vendor. Go mod, and go mod vendor is not required. So we'll just do the make install. Okay, hackathon v1. So we'll just do the CD complex and go mod vendor. So we'll wait for some time once I will go mod vendor is completed. Sorry. Am I audible, Salim? Sorry, my bad. So once we have actually installed all the Cosm version networks, we will all the Cosm version binary, we will our main aim will be to interact with our Comdex no one is testnet. So for that, we will actually be requiring the RPC endpoints. So in the Comdex no one exchange details, you will see that you can see that the RPC endpoint is actually provided, which is the HTTP RPC novanet.com. So you will just be copying it. And to actually interact with it, you can just type Comdex Q wasm and minus minus node. So I'll just brief you about how it actually works. Is Comdex is basically the binary that we have actually installed. Q stands for query, and Wasm is the Wasm module through which we will be interacting with our chain. So once you type enter, you will see that here are the list of available commands that you can see or for the Wasm module, which is a list code that will list all those Cosm Wasm codes that have been uploaded to our Comdex network. And Comdex list contract by code is something that actually lists all the code by contracts of being a once you provide a code ID, they will actually providing with all the contract details that are provided by the process code ID. And state goes to code info and code state, which we will be going through it in the later part of the session. And the second part comes in the context TX volume. TX stands for transaction. And once you break it down, TX has different way, like has different steps, or I would say different hierarchy in which a particular contract has to be uploaded and interacted with the users. So first, the store. Store you can consider as simply uploading a particular Wasm code, which has no usage until unless it is instantiated. So you can consider like suppose you have created a Wasm file where you have just created a contract where every time someone interacts, it updates a counter to by one. So uh, this is something like a code being uploaded, but has no instance on the blockchain. So then comes the part where instantiate actually works, where you provide instantiation and create an instance of a contract where it can actually where it can actually interact with users. So instantiate works in that particular way. Execution is something like once a contract is instantiated and has got a contract address, then instantiation and can like execution actually works on that particular part. Consider for an example that in Solidity, once we have actually compiled our code and uploaded to it, until and unless we once and deployed our code, until and unless we provide some instantiation values or parameters to it, no new contract address or instance of that particular code is created. You can consider a similar fashion where how it works in Cosm version, where upon successful instantiation, a new instance is created, and then based on that particular instance, you can actually interact that particular code, and based on your execution, the contract state is actually updated based on the transaction logic you have written. The most important part of this particular Cosmwasm contract is migrate as well as set admin contract, which we'll be talking in the later part of the workshop in coming days. But for now, we can actually understand how migrate works is. In Solidity, you can understand that once you have written a Solidity code, deployed it with some instance, it becomes very hard to actually point to some new code which has some new underlying logic to it. And that's where Cosm version actually steps in, where suppose as I have actually told earlier as well, like suppose I have a counter code where every time I interact with a contract and the counter is increment itself by one. Now here comes a new developer who just wants the same contract with the same state, but wants that every time someone interacts with it, it wants the counter to be updated by 10. Then in that particular case, he needs not to create a new instance for it. He can actually point to a same instance by just using the migration function for it. So This is the part of migration where you can actually add a new port to an existing contract instances. And based on that, you can, every time you just reiterate or make some more improvement in the code, you can just repoint to the same instance and continue from there onwards rather than creating a whole new instance and going forward with it. And here comes the contract admin. So this is the most important part of a particular smart contract where the migration is something that is only applicable for a contract admin. So I am being the admin of the contract. Only I have the ability to migrate my contract from one code to another without any governance proposal required. So this is the part of an admin where he can actually trigger migrations permissionlessly rather than going via root of the governance modules and the on-chain governance to actually migrate any contract from one state to another. So, and grant is something you can consider as like you are actually granting some authority from your address to some other address so that they can execute you can consider as a grant. So from the next workshop, we will actually focusing on how to create a NFT marketplace from scratch. And from there on, we'll be actually working with how to create a struct, then all the programming logics, and then and we'll end up with how to actually deploy your basically smart contract on chain and interact with it via front end. So Uh, here also one more thing to add is like since most of you might be familiar with like how wallets work in Cosmos. So I'll just give you a brief intro of how basically you can just create your own wallet in the Comdex ecosystem and then claim some few project tokens which you can use for development of your own project. So for creating a particular wallet, you just need to run Comdex keys, add, and your key name. So let's say my key name is temp1. So on executing this particular command, you will see that wallet has been created in my name with the context address generated there. And this is the my mnemonics which you must store or every time you create a wallet, you must particular mnemonics or you will not be able to retrieve it after that. So you can see that I have created a wallet named temp1 and now I just want to get some test tokens. So you can just directly log on to faucet.comdex.1, which you can see in the hackathon instruction guide as well. And go to Novanet, which is our Comdex hackathon testnet, and just enter your chain address and just clear this capture and send token. So I have requested for some test tokens, which is around 10,000 or 1,000 CMDX. So you can verify that particular balance via executing the command of Comdex queue bank balances and providing your node as well. So here you can see that you have actually got 100,000 CMDX as of preprocessed problems, which you can actually utilize for creating your interacting with the test chain or creating your own Cosmwasm contract. So with this, we'll wrap up the session, and with the next session, we will aim to start with a new Comdex project where we'll be actually creating a marketplace of NFTs where user will be able to create an NFT using the Cosmwasm CW templates, as well as put those NFTs in an auction where where the users can actually bid on that particular auction. So we will be bootstrapping that particular project from the scratch and see how the structs are defined from the grassroots and how the query and transaction actually work in that particular case. For understanding purpose and for the tutorial purpose, I would suggest of going the Rust book, which actually provides a Cosmwasm or basically Rust level knowledge. This is the code where so you can actually go through the docs.rust-lang.org where you can go through how Rust programming language actually works. And apart from that, you can go to the docs.cosmwasm.com where you can go through like how the architecture actually works on Cosmwasm and installing the prerequisites for it, whether it's Go or Rust, and how to set it up on your local machine, which is a prerequisite of building any Cosmwasm smart contract on chain. Please let us know if there's any issues or any. Please let us know if any queries you have as of now. You can just ping in the chat, and or as well as you can connect on Discord if you actually face any issue regarding the problem version or so for the development of any module using Go language. So for the next workshops, we would request everyone to have a brief with knowledge on how basically Rust works and kind of all the prerequisites get installed in your local system, which is basically the Golang as well as the problem, as well as the Rust packages and language installed. And also feel free to connect with us on Discord as well as Telegram, where we can actually help you in any cases possible. Thank you everyone for joining.